Good morning. Today we'll have a brief about what is a stack. Stack is a linear data structure that follows last in first out principle linear data structure because the data that we are storing will be stored or arranged in the linear form. Next is last in first out principle. Let us look into this with an example. The example is submitting note in classroom. Usually the last submitted note will be on the top of the list and this will be taken out first for the correction. That is, this will be the first note which is taken for correction. So, the submitting is considered as an insertion operation and taking out for correction is considered as a deletion operation. In a stack, the insertion operation is denoted by the push function, whereas the deletion operation is denoted by the pop function. This is the logical representation of the stack. Usually, the insertion and deletion takes place at the top of the stack. This is a push operation and this is a pop operation. Okay, come. Stack has a pointer called top. When this pointer points to -1, this indicates that the stack is empty. This is an underflow condition. Now let us look into different operations in stack. First is insert 12. As you already know, insertion operation is done using a push function, which is push 12. 12 is pushed into the stack. Now what happens to this pointer top? This pointer will now point to 12. Next is insert 8, which is again a push function. Push 8. 8 will be pushed into the stack. Now this pointer top will point to the element 8. Next is the stack full. The size of the stack is either static or dynamic. It is static in the case of array, whereas it is dynamic in the case of linked list. Now let us consider the size of this stack to be 5. The question is the stack full. This is done using the function is full. We have only inserted 2 elements and the size is 5. So in our case the stack is not full. This function returns either true or false. This is because this function returns only the Boolean value. Next is delete. Delete operation is done using pop function. Normally pops out the element which is on the top of the stack. Here the element 8 is on top of the stack, so this element will be popped out. So now the element 8 will be deleted from stack. Now what happens to this pointer top? Top will point to the data or the element 12. Next is display. Display operation is done using peek function. This function will display the element 12 but without popping out this element. Next is insert 13. It is a push function. We are going to push 30. Now again this top pointer will point to this element 30. Next is delete. This is a pop operation. This will pop out the first element which is 30. 30 will be popped out, so 30 will be deleted from the stack. this top pointer will point to 12. Next is again delete, which is a pop operation again. So this element 12 will be popped out. So 12 will be removed from stack. Now what happens to this pointer? This pointer will again point to -1. The next is stack empty. This empty function is used. This function returns a boolean value that is either true or false. In our case, top points to -1. That means the stack is empty, so it returns true. Some of the applications of stack are back button, undo, redo, and recursion. If we want to change the font size in our mobile phone, what will we do? We'll first open the settings. So settings get pushed into the stack. Then we'll open the display page. Then this will push into the stack. Then we'll open the font size. Then font size will be pushed into the stack. Once we change the font size, what will we do? We'll click the back button. Back button is a pop operation. So font size will be popped out. Now we'll move into the page display. Once if we click the back button again, then what will happen? This display will be popped out and we'll get into the settings page. If we again click the back button, what will happen? We'll come out of this setting page. Next is undo, redo. Common example is a Microsoft Word where we will perform undo and redo operations. Next is recursion. The compiler uses stack to call a function using another function. Time complexity of insertion operation is order of 1, which is a constant time. For the case of a stack with no elements, that is empty stack, or in the case of stack with some element, insertion is a one-step operation. Push 5. In both the cases, the operation is same. There is no difference. Next is deletion. Deletion also takes order of 1 time complexity. The topmost element in the stack will get popped out, irrespective of how many elements is there in the stack. Here, 5 will get popped out. Next is storing. Storing an element takes order of n time complexity. For example, if we want to store an element here between 12 and 8. For example, we want to store an element 18. Then what will happen now? The element 3 will get popped out. Then element 12 will get popped out. Now we have to push this 18 inside. Then push 12 inside. Then we have to push 3.